Good morning, ladies and gentlemen. Welcome to my webinar devoted to the topic of the offshore energy production and its considerations within the maritime special planning process. Let me first introduce myself. My name is Magdalena Matczak. I work at the Maritime Institute of Maritime University in Gdynia in Poland. I'm graduated in oceanology, marine biology, and most of my professional life was devoted to the management of coastal and marine resources. Before the Maritime Institute, I worked at the WASAP 2010 Secretariat in Gdańsk, which was devoted to the regional cooperation in the special development of the Baltic Sea region. In the years 2016-2019, I had an honor to be a part of the Polish team that elaborated the first maritime special plan of the Polish sea areas. That was a great experience, and I hope to share with you today my thoughts and my knowledge. Welcome to my webinar. My webinar will follow such, one could say, simple steps. I hope to give you responses to questions as what, why, where, and how. Easy questions, simple questions, but I can assure you that the knowledge behind those responses is really vast. And I hope that those 45 minutes will be enough to share with you everything. As you noticed, I'm not an energy expert. I'm a marine biologist, but I would like to share with you today my knowledge and experience gained during the maritime special planning process in Poland and during many international Baltic projects, which were also devoted to the offshore wind energy. Some of them you can see on the screen. The most important for me, from my side at least, are the Baltic lines, which ended in 2019, so it's quite a fresh project, which was devoted to the development of offshore wind energy in the Baltic Sea region, but also together with defining interactions with other main sectors like shipping or fishery or linear infrastructure. So this is a very good example of the Baltic cooperation. Another very good example of Baltic cooperation, which I will also show you today the results of the project, is a Pan-Baltic Scope project, which gained all the people responsible of maritime special planning in the Baltic Sea region to one table to discuss the most urgent issues. And one of them was also offshore wind energy and how to include it in our plans, how to think about the conflicts, how to make the country's plans to be coherent also with regard to the offshore infrastructure. Ladies and gentlemen, first about the definition, a short slide. Of course, we can say it's obvious. We all know what the wind farm is, but looking at the offshore wind farm, it's a little bit more complex and complicated issue. The offshore wind farm consists of three structures. The wind turbine, which is the main element of the offshore wind farm, and this is the main element that converts the kinetic energy from the wind into the electrical energy. So this is the generator. Then we have electroenergetic systems, so all the cables together with the offshore substations which transfer the energy to the land. And also we have measurement stations on the sea areas which are used for monitoring, for measuring, for research during the offshore wind farm operation. So you can see that this investment is quite complex, consisting of the maritime part and on the land part. Looking at the foundations, I would like to focus here on foundations because it's quite interesting, because it's also depending on the depth of the sea, of the localization of the offshore wind farms, and it's also the response to this very sometimes difficult question where to localize our investments. So the best, of course, is close to the sea where the depth is not so big, but then those areas close to this shore are sometimes very heavily used by other users, or there are quite huge society protests because they don't want the landscape to be polluted with the wind farms. That's why we have to localize our offshore wind farms further to the sea where the sea is deeper. That's why there are different foundations, which also depends on the substrate of the sea. If we have a rock, we can use another foundation. If we have sand, we can use another foundation. So here you can see on the first graph the different bottom fixed foundations type for the quite shallow waters, like up to the 50 meters of depth. On the second graph, you can see the different floating foundation types for offshore wind turbines. They are specifically used for the offshore wind farms, which will be floating, which means they will be localized in areas of bigger depth than on coastal waters, which means about 80 to 100 or even in more deep waters. Ladies and gentlemen, I would like to show you now the complexity of the investment. There is no single way to build and operate an offshore wind farm, and much depends on the specific conditions at the site. Also, the pace of innovation in the wind industry has been so rapid over the last decade that the new technologies are coming and the new solutions are entering into the market. So even if we have bad substrate conditions, the technological development can cause that the wind farm can be located in areas where the substrate is not so good for wind farms for such investment. But I would like to show you this picture because I want to make you aware of this complexity. Understanding this complexity is very important for understanding later the consequences for space, for marine space, for land space, for coastal space. It's also very important to understand the consequences for other users and the resulting interactions. So we can be aware from the beginning where the interactions will be, where the conflicts can be caused, and where we have to be aware. So let's see from the beginning, from the phase of development. The development is the phase, the project development phase, encompassing all the activities performed before the installation. So it means many research on place, consultations with other stakeholders, with the coastal communities, and so on. So we can see the environmental surveys, the ornithological surveys, the seabed surveys, and I have to tell you that this is really a great new knowledge created. So such an investment also creates a new knowledge about the environment, about the marine space, which is really also useful for research and science. When we go to the next stage, to the installation, then we can see how vast are the consequences. Looking at starting from the construction port on land, which is not very easy because such a construction port have to be a large port where enough space is secured for offshore wind farm elements, with sufficient capacity on land, with sufficient approach depth and sufficient length of piers, so the elements can be stored there and then transported to the installation place. So there is not a lot of such a ports in the Baltic Sea region. So this is quite an important issue to think before the investment begins. Where will be our construction port? Then during the construction, we have, of course, all the ships which are devoted only to the construction of the wind farm. So this is a huge impulse for the shipping industry also. We have offshore cable installation ships, also very specifically constructed only for this purpose, like foundation installations and so on, so on. The consequence for space in this moment is that the area devoted to the offshore wind farm will be closed for other users because there will be constructions on place, and also there will be a huge traffic between the construction port and the place where the offshore wind farm is located. So we have to be aware that during the construction phase, which lasts about 2 years, there will be quite a bigger ship traffic between the construction port and the offshore wind farm. When we construct already the wind farm and we start the operation of the wind farm, it lasts like 30, 40 years. We don't know because we don't have so old wind farms in the world so far. Then the most important, maybe not most important, but there are the servicing ports. They are different ports than the construction port. They don't need to be huge as the construction port. They can be regional ports which are located quite close to the offshore wind farms, where the servicing crew can rest, where the servicing ships can have their own base, where the helicopter landing places are provided. And also here we have to be aware during the operation phase that the traffic will be stronger than normally. So we will have a traffic now between the offshore wind farm and the servicing port. We will also have increased air transportation between the offshore wind farms by the helicopters, which will transport the crew or servicing crew to the offshore wind farms from the land. So we have to be aware about everything from the beginning to understand the consequences on sea, on the space, and on other users. Few facts about the offshore wind energy, ladies and gentlemen, but these are really basic facts only, because that could be another presentation devoted only about the facts about the offshore wind energy. So for sure, the offshore wind energy is currently one of the fastest growing energy sector in Europe. And I'm from the Polish perspective, I see it also in Poland, that this development phase now, the pace is so fast now in Poland that also the legislation is ready now for the development of offshore wind energy. So this is really a very fast growing sector. And of course, the offshore wind as a renewable energy source has several advantages compared to other sources of energy. So let's say that it's like making use of the technologies developed over decades by the onshore wind industry. The offshore wind industry based on the experience of the onshore investment. So they are not starting from the beginning. They are using the technology which was already developed years ago. So that's something advantageous. Nearly all offshore wind farms has taken place in Europe and especially in the North Sea. But we can also see the development starting in Asia in recent years. When regards the Baltic Sea, you have to be aware that the development in the Baltic Sea region is going in a different pace in different locations and countries. That, of course, depends on the economy of the countries and the readiness of the investors also to invest in such a huge investments in offshore wind energy. What is also quite interesting that compared to the North Sea region, the foundation types in the Baltic Sea regions, they vary. We can use more types of investments as the soil conditions and other environmental factors are more varying in the Baltic Sea region than in the North Sea. That's because the Baltic Sea region is very environmentally precious sea. We have a lot of protected habitats. We have a lot of different substrate types. And also in the Baltic Sea region, we have a quite huge issue with the ice cover in the winter time. Of course, I'm not talking now about Poland, but when we go north to Finland, to Sweden, to Estonia, the ice cover is a great issue there. And this technology, the foundation types are different than for example, in Poland or in Germany in the future. Okay, going further with my presentation, of course, a few sentences about the potential benefits stemming from the development of the offshore wind energy. So we can divide them into the three pillars of the sustainable development. So the social pillar, what is the benefit from the offshore wind energy development? So support for the labor market. Such an investment will create a lot of new places for work, and not only in the coastal areas, but involving all the country. So a lot of companies from the whole Poland or from the whole countries which is involved in offshore wind investment will benefit from the new labor places. In the long term, the offshore wind energy should impact and should result in a reduction of electricity prices, such are the economic analysis. It will also guarantee the stability of energy production and supply, so it will strengthen the energetic security of the countries. And of course, it's not that the offshore wind farm there are no conflicts with other users or social conflicts, but they are smaller, there's less of such a conflicts than with other energy sources. When we look at the economy of the countries, of course, there's a huge stimulation for the development of the national economy. There are new, as I said, new workplaces, and there are new technology needed, new industry needed. So everything is a great stimuli for the national economy. And of course, such offshore wind energy help the country to fulfill the targets of the European Union with respect to the renewable energy sources targets for 2030. Technological development, and in a longer phase, the reduction of energy production costs. Looking at the potential benefits towards the environment stemming from the offshore wind energy, of course, looking at the general global or even the regional perspective, this is the reduction of the emissions. So this is something what we are fighting now, the fighting against the climate change. It is still, of course, invasive for the environment, but less invasive than other sources of energy production like carbon, oil and gas. Ladies and gentlemen, now I would like to finish this introductory part, definitions and the short facts presentation. I would like to focus now on how to deal with the offshore wind energy issues within the maritime spatial planning. I would like to base my next slides on practical guide how to designate the energy infrastructure within the maritime spatial planning. This is a result, the report prepared by the Baltic Line projects, which I mentioned earlier. And this document, quite short document, I encourage you to make use of it in your daily work as a planner. This is really a practical guide showing step by step what to do, what to take into consideration while planning the marine areas. So let's look at the first step in our travel. At the beginning, we should look at the political goals for offshore renewable energy. Here you have a checklist from this report, so we should try to see what are the political goals for the development of this sector at the European level, at the global level, but also at your national level, because all of the countries should have their energy targets defined within their policies. So we should look at the political goals. We should try to transfer the more general objectives into the more detailed ones. So we should try to calculate the targeted megawatts into the space. How much space do we need? Of course, there are problems, which I mentioned at the beginning, because with the development of technology, we are constructing bigger and bigger windmills. That means that we can put more energy, we can produce more energy from the same space. So sometimes it's difficult to calculate because it's changing, but still we can take some average. Looking at the political goals, we also see what are the priorities for each of the country, what energy sources are prioritized for each country. It's also quite important thing for maritime spatial planning. We also should look at the priorities of neighboring countries. Why? Because the Baltic Sea region is a complex environment. Of course, we have borders on the Baltic Sea, but the ecosystem itself, the sea, it's not using those national borders. So we should be aware of the consequences of our neighboring countries' policy goals. So what is also important to be aware of the future trends and technological developments. Looking at the European level, of course, we have the European Union energy policy and the three main objectives which were set up in 2014, like the secure energy supply, ensure that the energy providers operate in a competitive environment, and that the energy consumption is sustainable and the decrease of green gas emissions is provided, the pollution and the fossil fuel dependence. And of course, we have the EU energy targets for all the years coming from the 2020 to 2015. So we should reduce our greenhouse gas emissions, for example, by 2015 by even 95%. We should sustain the renewable energy consumptions at about 66% by 2015, and we should support the energy efficiency, increase the energy efficiency by 21%. How it is mirrored in the national policies. So the national targets for share of renewable energy are set really individually for each of the countries. Here you can see the comparison made in 2019 during the Baltic Lines project, the comparison of all the countries. And of course, it's not to judge, it's just to see the information that it's going in sometimes in a different pace, as I said. And of course, you have to be also aware that some of the countries are still working on those national policies, like, for example, Poland. The energy policy of Poland up till 2040 was elaborated last year, 2020, and it was then adopted. So we have a new goals for this renewable energy. But you can see here that all of the countries has somehow defined the targets. So all of them should make the best to fulfill those targets. And sometimes the renewable energy have to take place on the sea areas because the land is not sufficient anymore. Here you have the example of the Polish energy until 2020. So with regards to the wind, it's even stated in a policy document that by 2020, 8 gigawatt should be installed at the sea areas. Another step, if we know the policy, if we know what are the national targets, if we know what the country wants, what are the national preferences, then you have to go and see what is the ongoing situation. So we should look at the areas already designated for offshore wind energy. Do we have such areas already? Do we have sectoral development plans, or do we have any other spatial plans? We also look at the other uses here, but most importantly, we look what is going on with regards to the offshore wind energy. So looking on the whole Baltic Sea region, this is the picture which shows the situation in 2017. This map was also developed during the Baltic Lines project. So you can see the points which shows each of the investments, but as you can see, most of them are at the early concept or early planning phase. Only there are some wind farms located on the Denmark waters and the German waters, but most of the projects are in an early concept of the planning. This is everything for the future. You can see here on this table the country with biggest number of the offshore wind farms in Denmark. There are 13 offshore wind farms, although those wind farms, sometimes they are quite small, and there are 3 under preparations. And like looking at Poland, Lithuania and Latvia, there are no existing so far projects, investment, but there are projects which are in a so-called pipeline. So project which has received the permits or the environmental impact assessments report are prepared already. Why is it so important to know what is the state of the art at this moment? Because we're looking at the Polish, at the assumptions for maritime special planning in Poland. It has been said from the very beginning that the location decisions which are issued for the offshore wind farms should be taken into account. So it's very important to know where are those future projects and in which phase of the project they are, because they have to be taken into account. Looking also at other assumptions of maritime special planning in Poland, it has been from the beginning said that the work should take into account to what extent a given sea basin is predestinated for the development of offshore wind energy. So special analyses have been prepared to check where are the best areas for the offshore wind energy. So the most valuable and the least conflicting areas are reserved for the future. Another one is that I already mentioned that the location decisions have to be taken into account, even if they are located not in the best areas, like in the conflicting areas, but they are legally binding. So we have to take them into consideration. What is also very important with regards to Polish planning, but also the similar assumptions have been provided by other countries, that it's necessary from the beginning to ensure that the safety and efficiency of navigations is provided. So then we designate the areas for offshore wind farms where we can secure the efficiency and safety of navigation. And here we also come back to the national policies and targets, because like in the case of Poland, the safety of navigation, transportation, sea transportation, and the development of ports is the main goal of the maritime policy. So this is the most important thing at this moment. So it has to be taken into consideration. And of course, also in the Polish process, we were thinking about the future. So what are the special implications of technological development? For example, do we have areas suitable for offshore wind farms as a floating structures? So not only thinking about today, but also thinking about the future. When we look at the example of Sweden, we can see that the process, the assumptions were quite similar. So the national targets have been taken into account. account. The new studies on the suitability and existing wind energy have been performed, and that everything was done in close collaboration with sector authorities. So you can see that all of the Baltic countries, they were working in a similar way. So those steps that I'm showing you now, they are kind of agreed or taken up by all of the Baltic countries. Going to another step, so we know what are the targets, national targets, we know what is important for the country, we know what are the goals of maritime policies of the countries, we know what is the existing situations, where are the binding licenses, where are the plans, and so on, so on. Then we try to map the suitable areas to see where are the other areas suitable for the offshore wind energy. And here we have some most important parameters for the wind energy development. This is the wind, the speed of wind, the water depth, and geology, and also the amount of energy in the coastal area, and also the possible grid connections. Those are the most important parameters used for the special analysis to define where are the best suitable areas for the offshore wind energy. Let's see here, I will show you some maps, as I said, showing the Polish examples, but I think all of the countries have performed similar analysis. So looking at the wind, this is one of the most important or the crucial parameter for the suitability of location of offshore wind farms. Typically, the wind speed is expressed as an annual mean measured in a specific height, and there is no the best specific amount of wind. The stronger, the better, let's say. And we usually measure the speed at the height of 100 meters or even at the height of 125 meters. This is the height where the generator is located. And of course, you also have to remember that with the technology development, the turbines will be bigger and taller, so the height will also have to be changed to higher. But let's see what is the potential of Polish sea areas. So you can see that at the height of 152 meters, the annual average speed is 9.5 meters per second, and this is a very good speed. So you can see that the wind conditions are very well at the Polish sea areas. Out of the different scientific analysis, we can see that the number of windy hours per year is 7,000 per year, and this is also a very good parameter which leads us to the efficiency of electricity generation to the 40% with regards to the Polish sea areas. Looking at another parameter, the depth, you can see here the map of the whole Baltic. So Baltic is not a very deep area, so this is good precondition for offshore wind development. The Baltic average 52 meters, and Polish sea areas average depth is around 53 meters. And of course, this is a crucial parameters for costs of such an investment. If we have deeper waters, then another technology have to be applied, and then the costs of the offshore wind farm installation is higher. But as I showed you earlier, the rapid development of offshore technology is also making those deeper waters available. We have floating wind farms in the North Sea already in place, so it's not a problem anymore, you can say. So looking at the Polish example at the beginning, you can see here quite shallow waters in the coastal part and a few deeper basins around the Gdańsk depth and Gotland depth and Bornholm depth. So you can say that Polish sea areas are very good with regards to the potential depths. And if you look at the parameter classification which we prepared for our maritime special planning, we classify them like every 5 meters to give them the value. So you can say that the more red value, the most suitable areas are. So we have one parameter classified, the depth. Another parameter is the accessibility to the grid connections, because it's not the case that you can put wind farm in each place and you are happy, then there's nothing to worry about. No, you have to connect this wind farm to the energetic grid on land. So you have to connect it to the connection point on land. And here we have a problem because such a connection points are not everywhere. They are put in some specific locations. Of course, we can build a new one, but this is also depends on the country itself. If you can see those black dots here are the connections to the national grids where the wind farms can connect. So for example, when looking in Poland, we have only such a 3 connecting points, which make it more difficult, and you have to think here very precisely how to lie your cables, how to use the space for the linear infrastructure. So looking again in the Polish example, as I told you, we have 3 connection points. Of course, they are not on the coast, but they are located further inland. But here you have localization of so-called landing areas, so where the cable is entering the land. Of course, here then you have to analyze what is the conditions on the land. Do we have national protected areas? Do we have here cities, or do you have cultural protected areas? Can we use this, looking at the technology, how we can perform the connection between the offshore wind farm and the online energetic grid? Such a parameter was also used for the analysis. As you can see, we have calculated the distance from the landing point. So of course, it influenced the cost of the investment, because the further from the coast the offshore wind farm is located, then the cost is getting higher because the cable is more expensive and the laying of the cables is more expensive. So this is another parameters which is taken into account when analyzing the most suitable areas for offshore wind energy. And also geology. Of course, the wind turbines required a solid ground to build on, but as I showed you earlier, the different types of foundations, technology is helping us, because even if we have a substrate that is not the best, it's not rock, it's a sandy or something, we can choose. Of course, that influences the cost again, but it's not the case that it's not impossible. Here, when you look at another parameter of classification, the substrate type, you can see that also the red ones are the best, the most suitable for the offshore wind energy. But you also have to remember that this changes with the different technologies. Such a classification, which I show you here, was developed in Poland in 2016. So now when we do a new analysis for a new technology solutions, maybe this map could look differently. If you put everything, all of the layers which I showed you earlier, so the wind, which have the same value over the whole Polish sea, it's not such important when differentiating the areas. But here you can see that the most important is depth of the water, and of course the geology and the distance from the grid. Here you have a result of the analysis showing you the most suitable areas for the offshore wind energy production. So of course the coastal areas are the best. Then we have the 2 shallow areas like the southern Midden Bank and Słupsk Bank. We have now the most suitable areas, but we also have to look at other uses and other circumstances influencing our research. Here you have we have placed the legal constraints and the environmental constraints. The most important legal constraint in Poland is that the offshore wind farm can be located only in the exclusive economic zones. The territorial water of the Polish Sea, they are excluded from the offshore investments. This is prescribed in a legal act, so it's binding and it's not so easy to change. Another environmental constraint are the protected areas. So in the exclusive economic zone, we have 2 areas which are protected by Natura 2000. So this is the Pomerańska Bay and Ławica Słupska. Those are 2 areas which are excluded from the investments. And you can see that they are covering those shallow waters very suitable. So you can see that the areas, they are left not so many of them. This is what we can take into consideration in our maritime special planning. Look at the different other sectors. So you can see here the Baltic view with those planned investments, with the environmental constraints like Natura 2000 and other protected areas, where you can see the ship density, so the main shipping routes, traditional shipping routes, and also the connections, energy connections between other countries. Here we come to another step. So we know we have made the analysis where are the best conditions for the wind energy, and now we have to look at the conflicts and synergies. I like to call them interactions, because conflicts are always a kind of negative. If we have a very good area located at the border with Sweden, we have to look what are the conditions, what is Sweden planning here, because we have to look at our neighbor countries. So when we know those interactions, when we discuss the nature of those conflicts, interactions, we can try to find solutions, find synergies. And of course, it should be discussed with other sectors and other stakeholders. Looking at these special conflicts, the most important and the most easy is that the direct competitions offer limited space. And this is the case, for example, of shipping. If we have a wind farm, we cannot have a shipping line on the same space, because especially when we are talking about the huge container ships, which are like going to be 400 meters long. So there is a direct competitions, and this is a kind of source of exclusion. They cannot coexist. The same is with some fishery activities. The experience showed that some of the countries like North Sea, they close their offshore wind farm areas for the fishery activities. This is quite complicated issue, and it's also have to be decided country by country, and even the investment by investment. It depends on the distance between the turbines. Another source of the conflict is that one sector negatively impact the another one. They are not in the same location, but they can impact negatively. And this is the nature of the conflicts with environment. Of course, we have a conflict new users versus old users. You have to be aware that the offshore wind energy is seen as a new user, a very ambitious one, very strong one. Sometimes people say very aggressive one with the huge goals, with the huge support. The traditional sectors like fishery, sometimes like regional transportation or the maritime tourism sport, they feel to be weak when talking to the new users. And of course, we have a weak planning process, like no transparency, not building trust, or wrong localization decisions which have been taken in the past, and we have to consider them in a maritime special planning. And of course, this is something maybe you are aware of. Usually we create such a matrix of interactions when we put the colors depending on the level of interaction. So the red one is that the conflicting, the C, the yellow that the users can be compatible under certain conditions, and the green one is that they do not disturb each other and they can even promote each other. They can go hand in hand. So when you look at the wind energy production, it's assessed to be conflicting with most of the other uses. So you can see that this is a problem with the shipping. As I said in the beginning, you cannot have a shipping lane going through the offshore wind farms. With all the developments like port areas and so on, this is exclusions. Yes, you cannot have those two developments in one place. Wind energy production is also conflicting with the military training grounds, which is a quite strong user in the Baltic Sea region. And this is also an exclusion because military training grounds, they have to be devoted only to military activities. We have also some areas in the Baltic Sea region which are areas of dumped explosives, of dumped munitions. Of course, you cannot do anything about this. This is something which is there. This is the state of the art. It has been there since after the Second World War. But you have to, during the planning process, you have to be aware where such areas are. You cannot plan any investment activities there. Here's the example of the interactions with other users. So we can see the examples of calculations of the safety distance between the shipping lane and the offshore wind farms. It's, for example, about 2 nautical miles, which allows the big ships to turn around in a case of emergency. Here also can see the distance which such a cable corridor requires. So there are distances between the cables themselves, also to ensure the safety of the installation, but it also depends on the investors. And of course, we also have to think about these positive interactions, so potential multi-use, so coexistence and synergy. Here are some examples of the multi-use depending on the type of and the dimensions. So the maximum, like let's say the coexistence that use the 4 of the dimensions, so the spatial, temporal, provisioning and functional, so it's taking place in the same time exactly with shared services and so on, so on. So there are different types of synergies of those positive interactions. For example, the proposed aquaculture is one of the solutions. You can use the offshore wind farm for the aquaculture purposes, or you can open the offshore wind farm for fisheries. They are taking place in the same space and in the same time. Ladies and gentlemen, I would like to show you at the end how the different countries consider offshore wind energy in their plans. Here you can see what is the role of the maritime special planning in location of the offshore wind energy. So looking at the Polish plan show you the suitable areas for locating. And it's not possible to build offshore wind farms in other areas. So you have areas only for wind farm and you cannot build it in another place. For example, in Sweden, you can see that the Maritime Special Plan suggests the new areas. This is more strategic plan. This is more guiding document. It's not so legally binding. In Latvia, identified the suitable areas, but offshore wind farms can be also located outside of these areas. So they are more open for further developments. This is a map from the HELCOM database where all the countries try to put their plan solutions into the one database. You can see here orange color the areas for offshore wind farming. So you can see here the Polish offshore wind farms areas and also the neighboring Swedish areas. We can see here also on the Danish part, here will be the planned wind farm. You can see at the Germany side where are those areas suitable for wind farm. So each of the country made the same exercise. They follow the same steps to come to the MSP plan and solutions within the MSP plan. Shortly about the strategies or scenarios which have been developed during the Baltic Lines project, for example, if we look only at the wind farm energy and do not consider any other users, in 2050, if we take into consideration the high scenario, so that we use all of the potential, all of those areas could be covered by the investments. But of course, this is not possible because we have other users, and that's why we have maritime special planning to find a balance between the different users. One slide looking at development trends. So I also talked about this earlier at the beginning, that the current trend is to build larger and more powerful turbines. So you can see this end at the 2016, now probably in 2021, these turbines are bigger. So what are the consequences? Of course, there are positive and negative consequences. From one side, such a bigger turbine, it means that we will have less turbines in the area because they can produce more energy. So we don't need like 100 of them, but we maybe need only 50 of them. So the impact of the environment on the bottom of the sea will be not so strong as with the smaller turbines. But from the other hand, there's a bigger impact on the landscape. They are visible from the land. Even if we locate them in the exclusive economic zones, which is more than 20 kilometers from a shore, even 40 kilometers from shore, they are still visible. They can be visible. They can somehow pollute the landscape. So that's also the result of the development trends. Of course, the less turbines mean less cables, and cable is also something that creates problems. It also creates problem to the environment, and it also creates problem to other users like fishermen or shipping or tourism. And the floating offshore wind farms, we have first floating farm at the North Sea high wind pilot park with 5 turbines at the depth up to 120 meters. And it's one of the positive is that it's further from the land, so it's not so visible. It goes to the deeper water areas where less conflicts are, which are maybe not suitable for other users. It can handle bigger turbines. So again, the cables, there will be less cables. And also the floating offshore wind farms, the turbines, as I show you, they have different foundations, not so aggressive with regards to the sea bottom. But of course, we are developing or investing in the areas which were unused. So again, our impact of the environment on the marine space is bigger. Further to the shore, we have longer cables, rising the cost, and which is the problem in the Baltic Sea region. Ice conditions are the problem for the floating wind turbines, wind farms. This is the big problem in the Baltic Sea region. And this is something for the very end, ladies and gentlemen. This is a kind of a song for the future. So now we are talking about such a, let's say, traditional offshore wind farm, but in the future, who knows how the wind farms will look like? Maybe we will have such a kite-driven offshore wind park or very large vertical turbines. We don't know what is in the future, and we have to remember that the maritime spatial planning have to think about the future. So we have to be aware, we have to be updated, we have to know about those technological use developments, and what most importantly, we have to keep the dialogue with the sector, because without the dialogue with the sector, without talking to people, to stakeholders, maritime spatial planners can be left alone. So, ladies and gentlemen, I hope you find this webinar useful, that I managed to transfer to you my experience and knowledge gained during the planning process in Poland. Thank you very much.